today we're going to be multiplying rational expressions. All right, these are the steps. Just like for simplifying, you have to factor your numerator, factor your denominator. Notice I wrote that. Factor your numerator, factor your denominator, cancel. And in order to cancel, one term must be in one of the numerators. Notice it just says one of the numerators because you've been dealing with more than one fraction this time. But one of the numerators and the other term must be in one of the denominators. So you need one in the numerator and one in the denominator. You multiply, you write down your leftovers. That's basically what it is. Now, this is starred. It says reduce. You sometimes need to simplify again. That will be because you didn't do something here correctly. But sometimes you don't see it until you're down to this step right here. And this step's just here as a precaution to be looking and making sure that you did everything like you should. All right. Now, when you see a fraction like this, there's no plus and minus signs. See, no plus, no minus, no plus, no minus. There's no factoring to do. The easiest way to handle this one is to multiply across the numerator. So you have 12, a to the third, a squared times a is a to the third, b times b is b squared, write that there. Then multiply across the denominator, 6 times 2 is 12, b squared, and c times c is c squared. And then simplify what you can out. So the 12s cancel out or go away or simplify out, however you want to look at that. There's one there. Same thing with the b squared. They totally go away. And the only thing you have left is a cubed over c squared. Okay, now this problem is the same way. Now I didn't, it looks like I did my canceling before I multiplied across, and you can do that. But honestly, I still think this is going to be the easiest. 5 times 21 is 105. X to the 5th power over 140. X to the 3rd. And then you simplify 105 over 140. That's going to give you 3/4. X to the 5th over x squared is x squared. Over x cubed is x squared in the numerator. That's because that's where your 5th power is. All right, now the difference between this problem and the one before it, this one, there's no plus and minus, so there's no factoring to be done. Example 3 has plus and minuses in the numerator and in the denominator. So you've got to factor each and every numerator and each and every denominator. Now, I have a GCF here, so I'm going to pull 4 out, and when I do, I'm left with y plus 2. I'm going to pull a y out of the denominator. That leaves me with y minus 2. Now, these are already factored. That's what you get when you factor. Look, y plus 2, y minus 2, that's what you get. Now, so, and remember what I wrote about one term must be in the numerator and the other in the denominator. So we have y plus 2 in this numerator and y plus 2 in this denominator. Then we have y minus 2 in this numerator and y minus 2 in this denominator. Those cancel out. You're left with 4 in the numerator and a y in the denominator, and that is your answer. Okay, again, factor numerator, factor denominator. So we're pulling 5 out of this. That leaves me with x plus 5. This is a trinomial. So you want factors of 6 to add to be 5. That's 3 and 2. All right, this is factor. These are already factored, so just write them down like they are, and then cancel out what you can. X minus 3, x minus 3. X plus 5, x plus 5. Remember, one has to be in the numerator and one has to be in the denominator, and we're left with 5 over x minus 2, and that's your answer. Now this one, the reason this problem is up here is because it does not have a denominator, the first fraction. So when there's no denominator there, the denominator is 1. And then x squared minus 16, that's the difference of 2 squares, remember? So you square root the first, square root the last, and put a plus minus. Now, I have x minus 4 in this numerator and x minus 4 in this denominator. And I'm left with x plus 5 over x plus 4. This one has a GCF of 2n. You take 2n out, you're left with n minus 5. This one's a trinomial. It factors to n minus 4, n minus 5. This one's a trinomial. It factors to n minus 4, n minus 4. And this, of course, does not need to factor. All right, so we cancel what we can. We've got an n minus 4, an n minus 4. We have an n minus 5, an n minus 5. And no, it doesn't matter which n minus 4 you cancel this with. I could have canceled it here instead of here. Okay? And then 2 goes into 4 2 times, and n goes into n squared n. So now I'm left with, in the numerator, I'm left with n minus 4, and in the denominator, the only thing I have left is 2n. Thank you.